In this example, we're going to take a look at how to calculate the distance between a point and a plane. Okay, so let's first take a look at this diagram here to get an idea of how the calculation goes. The shaded beige region here, it represents the plane. And we have some point Q that's away from the plane. And we're trying to calculate this vertical distance d from Q to the plane. So the hard part about trying to calculate this distance is we don't know the point on the plane that's directly beneath Q. However, what we can do is the following. So instead of trying to find this point here, we can take any point on the plane. Right, so in particular here, some point P is chosen, and then we form the vector from P to Q. And now, of course, this distance is not the same as D. However, we can use this vector and project this vector onto the normal vector. And even though this portion here is away from D, the nice thing about vectors is it doesn't really matter where they're located, right? So the magnitude of this vector is actually exactly the same as D. So basically, to calculate D, we calculate the magnitude of this projection, and it's going to be the same. And that's essentially what this calculation does here. Okay, so now let's apply the formula to example 4 here. So we're asked to calculate the distance between this point Q, 1, 5, negative 4, and the plane given by 3x minus y plus 2z equals 6. So to apply this, so we know the normal vector, right? Because that's just the coefficients coming from the equation. Whoops. So the normal vector is just the coefficients coming from the equation for the plane, right? So the normal vector is going to be 3, comma, negative 1, comma, 2. We know the point Q, however, we don't have a point P, right? So we want P to be some point on the plane, so we need to find that. I mean, it doesn't really matter which point P we locate, right? So we can just choose some values x, y, and z that satisfy this equation, right? So, we try, say, x equals 0, y equals 0, and then find the z coordinate from there, right? So what do you get? 3 times 0 plus 0 plus 2z equals 6. So you get z is equal to 3. So we can take as the point P coordinates 0, 0, 3. Okay, so taking those coordinates for P, now I have all the ingredients to do this calculation, right? So what is the vector PQ? The vector PQ is 1 minus 0, comma, 5 minus 0, comma, negative 4 minus 3. So that's 1, 5, negative 7. And so what is the calculation we need to do? The dot product with n. So that's 1 times 3 plus 5 times negative 1 minus 7 times 2. So this is 3 minus 5 is negative 2. Negative 2 minus 14 is negative 16. And then the magnitude of n is the square root of 3 squared plus negative 1 squared plus 2 squared. So that gives me 9 plus 1 is 10, plus 4 is 14, so square root of 14. And so finally, the distance d is the absolute value of negative 16 over square root of 14. So which is 16 over square root of 14. And if we want a decimal number, we can just quickly calculate that. So 16 divided by square root of 14 is equal to 4.2762. Okay, so that's calculating the distance between a point and a plane.